Hello everyone, now we are on live.
Good evening, everyone. Welcome to Day 6 Bootcamp on ML by GIRLSCRIPT. So, we are going to towards doing your assignments in a best way. And be regular with your assignments. This is the only thing we insist you every time. Be regular with your assignments in order to get your grades. Okay. So tomorrow will be last day where we will also give the projects and you can have the final queries done and we can discuss something more. Today, answer will start now.
Yeah, yeah. Thank you, Shishma, and thank you, Kannan, for today's session, for meeting today's session. So I hope the workshop is going good. So hope everyone is able finishing your assignment and submitting. So I'm interested to submit. I mean, see your assignment in different way, different perspectives. So many of the students are did very well of your assignment. So good and well. So before starting my class, I want to instruct something on for tomorrow. So today I'll be finishing off this course of ML. So tomorrow 7 o'clock have an exam. Okay, have an exam. So during that 7 o'clock the exam link open in. We will be putting in comments. So you have to submit your questions within half an hour or 45 minutes. It depends upon the questions. Okay. So the questions will be in Google link. I mean, it is in Microsoft Form link. Okay, this will be open from 7 to 7:45, I think so. So you have tried your questions. I mean, the questions will be there. You have to just try to answer in the question itself. So it will be both objectives and programmatic questions will be there. Okay, so I mean the questions will be in the base of Pandas, NumPy, and the Python programming. You have tried it. So if you have any queries of this quiz, you can put it in a respond during the, you can put in a comments for tomorrow after 7:45 to 8 o'clock. I mean 7:50 to 8 o'clock. During that time, we will be think of it. We will be answering the question. So before that, around tomorrow or today after tomorrow, you'll get a mail of regard. I mean, you will get a mail, not a mail. For example, while submitting your Google Microsoft form, in that form itself, you will be asking which project you are going to use. I mean, there will be around 10 types of different projects will be there. You can choose any one of the project. Okay. So we will be guiding you of any if you have any difficulty to solve many kind of problems in machine learning. Okay. So you can ask me of anything of during any time. Okay, just put on mail me. I will be giving you as soon as possible. So that's what I instruct you for tomorrow class. Okay. So let's move into today topic. So today topic will be seeing the interesting topic of machine learning. Okay. Sorry. Yeah. So today will be day 6. So I'm Anand. I'm from Sona College, Professor Sona College of Technology, and I'm head of Salem School of AI. So today topic will be the basics of ML, that is basics of machine learning. Okay. So why we are here? The first will be what is machine learning, why you are taking this course, and what topics should you see that covered with it. That doesn't really say. Okay. The first will be the machine learning process. Okay. So what is machine learning process then? We are just interact with just what is displayed in a screen. The first will be the data objectives, then data gathering, then data preparing of data exploration, building a model, then model evaluation as well as the prediction. Then you get the objectives. So this is machine learning process. So from this, what I'm trying to say here in the sense, for example, you have here your first step you have to define your objectives of your project. For example, you are the final student, so you have to I mean you are interested to some project in machine learning domain. Okay, the first step you have to think of it. What is your objectives? Okay, what is your objectives or what is your problem statement? Which problem are you are so able to solve by helping a machine learning? That is a define of objectives. You have defined your objectives. Then after finishing the objectives, you have to collect your data. Okay, that is a collect your data. So what are the data you need to complete your project? That is a data gathering. Then preparing of data is nothing but, for example, you have, I mean, for example, you are taking some picture in your mobile. Okay, anyway, you will take a one type of object within 3 to 4 different images because some of the fluctuations or some of the noise will be, some of the blur, everything will be there while taking your pictures. So that is that you have to remove by manually. That is a preparing of data. Then data exploration. Okay, the data exploration is nothing but that is data visualization. How it will be there. You have to split by training as well as testing. That I will tell you later. Then after you have to build your model by using any type of machine learning algorithms. Then model evaluation. How the model is evaluated, how model is trained happen. That is your training accuracy, testing accuracy, then validation accuracy that you have to evaluate. Then finally, you have to source of prediction of different types of data set. You have to apply in your model. What is our output? That is a predicted output. Okay, if not, if my output is not good, you have to change some of the fine tuning of algorithm or change type of any algorithm. This is a machine learning process. Okay, so before starting, what is machine learning? The general definition in Wikipedia: machine learning is a branch of artificial intelligence concerns the construction and study of system that can learn from data. Okay, this is very important. That learn from data. Okay, the system have that learn from data. This is the machine learning process. Okay, so these are the different definitions of different authors. First is the machine learning is a programming computers to optimize a performance criteria using example data past experience. Okay, so this is nothing but uncovered patterns to predict a future. I mean, both are same. The definitions of the way of teaching is different. That's it. I mean, the way of written is different. This is the different type of machine. I mean, different definition of your machine learning. Okay, so machine learning is my point of view. Machine learning is about predicting the future based on the past. Okay, predicting the future based on the past. I'll give an example, real-time example. Hope everyone using the Android mobile phone. In that Android mobile phone, you are taking some weather data. Okay, for example, you are in Coimbatore. In Coimbatore, what is the current weather? Okay, so whether it is rain, now the weather will be 32 degree. In that, whether the rain will be coming or not. Whether rain is coming or not, that is a machine learning. Okay, how it is because of lot of parameters, that is humidity, saturation, the futures extractions of particular weather. During that process of machine learning, whether will be predict rain will be happen or not. Nowadays, it is telling the 60% of raining will be there, 40% of raining will be there. It depends upon the more number of future. Okay, this is the predicting the future data by use of past data. This is a machine learning. Okay, so here this is the machine learning process. I already told we have a data set, then data cleaning, then future engineering. After that, you have to split it by training and testing. Testing is with your new data. Then you have machine learning algorithms. Then you have train your model. For testing data, you have to evaluate your model, but you get the score. Then you have to deploy your model. Okay, this is the entire stage of machine learning. So this is the machine learning, that is data collection, data cleaning. In the data cleaning, you have to data testing and data training should be split up. Then model validation, you have model testing, then deployment. This is the machine learning process sequence. Okay, so what is machine learning and does it matter? Okay, this is the same thing what I told in the last slide, same definition. Okay, so these are the applications of ACA. That is ACA is this application. The machine learning application is data mining, is one of the major applications. Data mining, then statistics, then pattern recognition engineering, then signal processing, electrical engineering, then induction and optimization. Optimization is a very vast area. I mean, was not a vast area in your machine learning. Okay, optimizing your algorithm. That is the first objective of your project. This should be the first objective of your optimizing some of the existing algorithm by use of some other parameters. So that is optimization. Okay, this is the machine learning application. Okay, so machine learning problems. See here, you have a data. In the data have some example. For example, red apple, green apple, then yellow banana and green banana. This is data. This is also one type of data. This is also one type of data. This is also one type of data. Okay, these are the data. Okay. So before starting the application different types of machine learning, I will tell you different machine learning algorithms. Here there are generally the machine learning is there. In the machine learning, the branches will be supervised, unsupervised, and reinforcement learning. Okay, generally, all the machine learning algorithms is generally it will be split by three different types. The first one will be supervised, unsupervised, and reinforcement learning. Okay, in the supervised, you have two different types. The one will be the classification, and another will be the regression. Same thing, unsupervised, you have two different types, that is clustering and dimensionality detection. Okay. Then you have a reinforcement learning. In that reinforcement learning, you have here that is reinforcement learning is nothing but just a game of A. Okay. There all I mean a lot of games is there that will be the reinforcement learning. Okay. So this is how you have to be there. There's a machine learning algorithms. So we will see one by one machine learning algorithms detailing. Okay. The first will be the supervised machine learning algorithms. Supervised machine learning algorithm is nothing but the data set itself. They will be given the labeled example. Okay. So what are you trying to say in the sense? For example, you have a red apple. Okay. So I make it as label B, label one. Okay. Label one is it can be any birds. For example, I'm giving this will be red apple. This will be green apple. This is a label. And then this will be yellow banana. Then this will be green banana. This is the different labels you have to make it. For example, this is the red that will be label 1. This is green apple that is label 3. This is not label 2, it can be anything. Label 4, then label 5. So supervised machine learning is nothing but supervised learning is given labeled example. Okay. Okay. So next is what is the data and goal. Here data is nothing but you have a set of records, also called as example, instance cases that is described as your some attributes. This is the data. Then a class, each example is labeled with predefined class. Okay, that is a supervised machine learning. Okay, supervised machine learning is nothing but it can be predefined classes. That is label will be label should be there. What is your goal? The goal is to learn a classification model from the data set that can be used to predict the future of your data or test of your data. This is a goal of your machine learning, supervised machine learning. Okay. This is a general difference between supervised and unsupervised learning that I will tell you later. Will be moved here. Supervised and there are two steps. The first will be the learning, then second will be the testing. So general learning is nothing but training. Learning is nothing but the training. How the train will be learn a model using some training data. Learn your model using some trained data. What is testing? Test the model using unseen test data. I'll tell you what is that unseen test data. So general accuracy will be number of correct classification divided by total number of test cases. General accuracy formula, number of correct classification divided by total number of test cases. This is a supervised machine learning, two steps, learning and testing. Okay, so here we have a set of data sets. It has triangle, then hexagonal, circle, triangle, then square, then rectangular, diagonal, rectangle, is the trapezoidal, everything will be there. So what is my goal in the sense? Our machine learning, our supervised machine learning algorithms has to be split into the similar shape of your images. Okay, so the first will be, it will be split by circle. It will be split by circle. For example, here a circle is there, here circle is there, here circle is there. These are the similar, that will be split into one data type. For example, this is class A, this is class B, this is class C, this is class C, this is class E, this is class F. Okay, so this is how to split it by your data set. So that it's become supervised machine learning. That is finding a similar patterns of your images. Okay. So what is generally supervised machine learning algorithm saying? See here, you have input raw data. This is your input raw data. You have to feed into algorithm. Before the algorithm, there will be you have to split by you have a supervisor. Supervisor is nothing but the user. Okay, the user has to be labeled it. After label it, you have to split it by training and testing. Okay, training and testing. So what is training and testing in the sense? Okay, what is training and testing in the sense? For example, you have a 100 images. Okay, for example, you have 100 images or 100 different data types. 100 images will be there. In the 100 images, so you have to split it by 60 is to 40. Like 6 is to 4. For example, 6 is to 4 is nothing but 6 having the number of training data set, 4 having number of testing data set. Yeah, 6 is to 4. For 6 is to 4 is nothing but 60 is to 40. I have 100 different images. So in the 100 images, I am taking a part of 60 images for training. So the remaining 40 images for testing. Okay, so in the 100 images, 6:14 means 100 images. In the 100 images, you have 60 images for training, 40 images for testing. If my algorithm is 7:3, so 70 will be training, 30 will be the testing. This is a supervisor. Supervisor has to be do. Then you have algorithm, it will be process your corresponding output. You see here. So generally, supervised machine learning process is nothing but it is displayed here. See here. The first will be training data, testing data, data labels, data cleaning, create a structure, then split data. That's what I'm told in last topic. Before. Next, you have to extract your feature, then coding part, then deduct information, adjust self, continue repeating your unself predictor. That is algorithm. Okay. So here next, what is model for step 4? Processing, testing, and training will be happen. The final stage will be prediction, validation. The shuttle between step 5 and step 3. For example, while validating my algorithm, it's not quite good in the sense. What you have to do in the sense, you have to come back into step 3. You have to fine tune algorithm, or you have to change your algorithm for predicting your good result. For getting not predicting, for getting your good results. It depends upon your how the data set is well and good. Okay, the shuttling between step 5 and step 3 in the sense, my validation part is not quite good in the sense our algorithm has to be changed. Okay, then after algorithm you have to change, then you have to you get maybe or may not be get your good result. Okay, this is the schedule between your 3 and 5 and 3. This is supervised machine learning process. So see here, this is the simplest example. Here I'm using naive bias. Naive bias is one of the supervised machine learning. For example, I have Kitty is here, my mail ID, my mail. So I have a Bayesian theorem. Okay, so I want to check whether this is spam or not spam in mail. Okay, for example, so in Kitty is for example, we have a 700 people, different 700 Gmail account is there. In that 700 Gmail account, 672 times of 672 Gmail accounts, Gmail account persons are telling this is not your spam. This is not in spam. So the remaining 13 people are telling this is spam. Okay, it will take the probability. The probability definitely will be more for 672 because 672 people are telling this is not a spam. So what our machine learning will do is it will be learn automatically. This is not a spam. So whenever the mail is coming to new person of around 701 person, I mean the 701 person, in that 701 person, automatically the mail will be going into the primary. Okay, it won't go to the spam. Okay, for example, I will tell you one more time. We have a 700 people. In that 700 people, 650 people are 670, 670 this 650 people are assuming this is not a spam. Remaining 50 people are telling this spam. So I want to calculate the probability. Definitely spam will be high. I mean, not spam will be high. So what our machine learning algorithms will do is it will be automatically training for Kitty. Whenever the images has to be coming to 701 person, that is new person to coming the same mail, automatically it will go into the either primary or some other primary or updates that will be for forums that are there are a lot of tasks will be there. Just assume that is general inbox. Okay, it won't go to the any spam. For example, the another example I'm telling. For example, my algorithm, I'm getting new mail. In that mail, around 350, around 600 people are telling this is spam. 100 people is not telling is telling there is 100 people are telling this is not spam. So same thing will be happen for training. So whenever that 701 person is coming the same email, so automatically will move into the spam. So this is how the spam filter to be working properly. Okay, that is naive bias algorithm. This is the example. Okay, so that is an example. Data, task, and performance. This is general things, not maybe better. Is not quite tough. Okay. So here, this is the supervised machine learning algorithms. You have a data, then model and predictor. You'll get a predicted label. For example, this is a apple. Okay, this is a yellow apple. So it should be printed. The model has to be tell this is apple. The model has to be tell this is apple by use of training. Okay, that is a supervised learn to predict a new example. Okay. So this is general supervised machine learning. That is error equal target output minus. For a target output, actual minus nothing but. For example, I am giving a character of A. Okay. For example, I am giving the character of C. This is C. I am giving this is image. The super machine learning algorithms, I am getting instead of C, I am getting O. Okay, but I desired output is what? C. So this is the error. That is target output minus actual output is the error. Okay. Okay, same thing. Okay, here there is the classification and regression. Classification is nothing but this is apple, this is also apple, banana, banana. This is a classification has finite set of labels. But regression is nothing but you have a real value. The regression values, that is discrete values. Okay, so regression example will be car attributes. Okay, you have to predict your price of your car. We'll see the example later. Okay, this is the difference between classification and regression. So there are two different. Classification is nothing but it is a discrete. That is a discrete set of values, and then regression will be the continuous value, continuous types of value. Okay, and then is the dependent variable is here categorical, and then here dependent variable are numerical. Okay, here the dependent variable is categorical, and here dependent variable are numerical. Okay, then the difference between classification and regression is same thing. Okay, so these are the applications of classification of supervised machine learning. The first will be the face recognition, character recognition, spam detection, medical diagnosis, and biometrics. Okay. Next is regression. Regression example will be predict the stock values, then average only the car plane value, then temporal, that is weather over the time. These are the regression application. So this is another example of machine learning. Okay, that is supervised machine learning. That is a ranking example. For example, I am typing in Google for machine, just typing in machine learning. It will tell you the about of 1/3. I mean, that is sum of 32. I mean, 13 core of results will be there. Will be there. The first result is coming in Wikipedia. Okay, why it is coming? The Wikipedia is a first in the sense a lot of researchers, a lot of resources, a lot of people are studying the studying in Wikipedia. So it seems the Wikipedia the result will be quite good, better than any other result. Okay, that's why the ranking example will be coming into the picture. This is the example. Okay, the same thing. Okay, it's okay. Next is unsupervised learning. So unsupervised learning means you cannot give the. I mean, there is example. I mean, you have the set of images will be there, but you don't give the your labels. Don't give your labels. See here. So here data set will be there. Here unknown output, no training data set. Okay. So I want to interpret. Then I have algorithm. It will be automatically cluster your different way. There is a automatic. It will be captured by feature extraction. Okay. See here, this is another example. You have apple, banana, then orange. You have interpretation, you have algorithm, you get the clustering. It will be automatically cluster will be for green apple, for apple it will be coming to one picture, banana will come into the one picture, orange will come into the one cluster. This is the same thing. There is a Tom and Jerry. It will be automatically filtered by Tom and Jerry. This is applications that is a cluster group without any label. That is grouping of people, image compression, then bioinformatics. Okay. So this is a comparison of supervised and machine learning. Here the input will be there. So annotations. Annotations nothing but these are apple. It is label. So you have a model. You have to give new data. It will be tell it is an apple. But here, so unsupervised machine learning, you have data. You have a model. It will be automatically clustered into different. Okay. Next is reinforcement learning. So reinforcement learning is nothing but by users of reward points, you'll get the reinforcement learning by properly. I'll give that example. See here, you have an apple. Okay, you have an apple, but our response, I mean, our system is our machine learning is telling it is tasting mango. So what it will be, the feedback it will be. I mean, we know that is not orange. That is apple. So the feedback we have to give in the wrong. It is an apple. Okay, what it will do machine order to do our machine, it will be loaded. Okay, DC noted. So whenever you are giving the new images of apple, definitely the system will tell you this is an apple. Okay, that is a what reinforcement learning. It will take the feedback of rewards, then it will be automatically tuning by your point. Okay, you have input, then you have an it is you have input is apple, but the system is telling it is a mango, but we have to tell me whether it is not a mango, it is an apple. That is a reward point. Okay, then it is our machine will be noted. Then you have to give the new system of your new images of apple. The machine learning algorithm will tell you this is an apple. That is a reinforced response. Okay, so this is the TikTok toys example of reinforcement learning. Hope this everyone knows. That is x0, but if it is x means the next will be 0. It will automatically by uses of A based. Okay. Okay. Next is the types of different methods, that is supervised, unsupervised, and reinforcement learning. These are the difference. So here, see here you have a training, you have input, you have training, you will get output. Here input and output will be there. Here you have input, you have output, that will be given to the feedback of rewards. Okay, this is the different types of machine learning. Okay, I'll continue here. So today we will be seeing the important topics of supervised machine learning, one of supervised machine learning algorithms. So that is a linear regression. Okay, so linear regression is the first algorithm for machine learning. Hope everyone knows. Okay, what we will be see about linear regression detailing. Okay, so here there will be three different types of designing your linear regression. The first will be the gradient descent, then least square, then linear regression minutes. You can take a linear regression by within 5 minutes of your time. If you have data set, is good. Okay, so the first we will be seeing one by one. What is linear regression? Okay, so what is linear regression is nothing but, see here. So linear regression is nothing but you have a data point. The data points are my marked as scatter plot. Okay, I have marked as scatter plot. So scatter plot is nothing but you have you have a data set of x and y that will be pointed out. Okay, so what is our goal? You have to fit the best line for your fitting your model. Okay, for baseline you have to fit your model. For baseline you have to fit your model over here. Okay, so you'll see how we will be seeing how it will be working properly. Okay, okay. So what is linear regression means? It is a approach the model relation between independent variable and one or more independent variable. Okay, linear regression is the model is the relation between a dependent variable and one or more independent variable. What I'm meaning in the sense, you have if it is there is linear regression have by two different types, that is simple linear regression and multiple linear regression. Simple linear regression is nothing but you have one dependent variable and one independent variable. I'll tell you what is one dependent and the independent. Then if it is multiple linear regression, you have one dependent, you have one or more independent variables. Okay, so that is what I'm saying here. So if it is one independent variable, sorry, you have one independent variable, then it is called simple linear regression. If it is more than one independent variable, that will be multiple linear regression. Okay. Okay. So here next is the line equations. We know the line equation will be y is equal to mx plus c. Here the line equation will be y is equal to mx plus c. So here this is the, for example, this is my line. C is nothing but your intro. Then mx is your slope. Mx your slope. Okay, the slope of your the slope point. Okay, this and this is that is dy by dx. Okay, hope everyone knows. So this is the line of your point. This y is equal to mx plus c. This is x. This is will be y. We'll see how we have this is the line equation. Okay. So what is loss function? This is very important topic. What is loss function? Loss function is nothing but you have a data point. Okay, you have a data point. In the data points, I'm getting some results. Okay, that result, then I'm having the original result. If you have to compute the error, for example, my output is 1. Okay, my output is 1. I am not getting 1. I will get 0.8 something. Okay, for example, I have a 0 value. I mean, I have a 1 value, but I'm getting 0.7. Okay, if it is 0.7, but the error will be what? 1 minus 0.7 will be 0.3. Okay, but what I'm trying to say? My actual output is 1. My predicted output is 0.7. Okay, I will tell you example later while doing. My actual output is 1. My predicted output is 0.7. So the difference between this and this will be 0.3. This and this one will be 0.3. That is the error. Okay, so here that's the error. 1 by n, that is the total number of samples. Yi is nothing but your actual output. Y cap is nothing but your actual output. Why I am squaring, since error should not be in negative sign. Okay, error should not be in negative side. Okay, then The last is the error is our predicted value of M and C. Okay, that is predicted value of M and C. Our goal is to minimize the error to obtain the most accurate value of M and C. Okay, most accurate value of M and C. Okay, so what is mean square error functions to calculate the loss in sense? Find the difference between actual y and predicted y value. Okay, so predicted is nothing but y is equal to mx plus c for given x. Then square the difference, find the mean of your each value. Okay, that's what the formula. E equal to 1 by n summation I equal to 0 to n yi minus y cap of whole square. Okay, so here the last function I'm continuing. This is e equal to, so e equal to, we know 1 by n summation yi minus y I cap whole square. Okay, so y cap is nothing but m into xi plus c. Xi is nothing but number of features. You have no number of input. Okay, so yi minus y cap. Y cap is nothing but mxi plus c. Okay, so here this is the last function. So here, before starting the linear regression, I want to tell you gradient descent algorithm. Okay, so gradient descent algorithm. So what do you mean gradient descent algorithm in a sense? For example, a person is standing in a top of the building, top of the tree, top of the hill. Okay, so you want to come into the goal is what in say you have to reach your lowest part of your hill. That's the destination. Okay, so what I'm trying to say in the sense, the steep slope of value of d is high, so takes losses. I mean, the divergence will be the steps will be high in the sense he may not be reach your destination. For example, I have like this. Okay, so I'm moving here to here, then 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 I'm moving here to here, like this. If it is steps is more, but my steps is small. Okay, if my steps is small, I will move here, then here, then here, then here, then here, then here, then here. Here is a small position. So definitely I will reach the finite position. That is a minimum position. That is a local minimum. Okay, so gradient descent is nothing but it is an iterative optimization algorithms to minimize your function. Minimize is nothing but your how to reach a goal by uses of minimum point. That is a minimum point. Okay, so but this is also minimum. This is also minimum, but this are all global minimum. This is the local minimum of your point. Okay. Okay. So next is applying gradient descent to M and C to the approach. Okay, it's nothing but see here. You have a data point that is we know the loss function will be this one. Okay, e equal to 1 by n. That's the value. Okay, so what I'm trying to do is I want to differentiate with respect to M and C. That is dm and dc. If I am differentiating with m with respect to m, okay, so this 2 will coming into here. So 2 by n summation yi minus m xi plus c. Okay, so with this differentiation, I want to use this also. So m into xi, m will becomes 1, becomes minus xi. If I am differentiating with respect to m, okay, that is dm. Okay, if I am differentiating with respect to c in the sense, I'll get 2 by n summation yi minus mxi plus c. I won't get any value because mxi is plus, then I don't have any c value. So c differentiation will get only 1. There is no issue. Then we will get this answer. Let me check it here. See here. So dm is with respect to m value, that is 1 by n summation of I equal to 0 to n. 2, the 2 square, I mean power square will be coming into down, yi minus mxi plus c of minus of xi. Okay, then dm is equal to minus 2 by n. Okay, minus 2 by n will get xi into yi minus y cap of whole square. Okay, this is how to do it. Okay, so here, see here. So here DC is nothing but same thing we have with respect to C value. Okay. Okay. So here what I am trying to say in saying here these are the two different parameters to learn by new value. What I'm trying to say is this M is nothing but this is new value. This is also new value. This both are new value. This is nothing but old value of M. Okay, here L is nothing but learning rate. L is nothing but your learning rate. The learning rate is definitely it will be 0 to minimum 0.01. There's not more than 1. It should not be more than 1. Okay, so it won't be good. So DM and DC is nothing but that is a DM value we have it, then DC we have it to a computer. This and this DM value. Okay, so here we have to compute new value by use of old value. Okay, you have to compute new value by use of old value. That is mu equal to this is old value. This two are m and c. This is old, then learning rate, then differentiation. Okay. See here, the first initially you have to m and c are 0. Let L is our learning rate. This controls how much the value of m changes with each step. Okay, L could be a small value like 0.001 of good accuracy for getting a good accuracy. Then second value, calculate the partial derivative. Calculate the partial derivative of the loss function with respect to m and plug in the current values of x comma y. Okay, this is the current value of derivative of value of d. Then similar for c also. Then we update the current value of m and c using the following this equation. We repeat this process until our loss function is very small. Our error should be minimized. Okay, so ideally 0, but which means 0 error means 100% can do 0.001 or 0 point something will be there. Very small. Okay. Okay, so I'm implementing the linear regression using Python. The first approach, that is a graded descent approach. See here, the first will be import pandas as PD, import numpy as NP, import matplotlib as PLT. Okay, so before that, I want to say the data set. See here, this is my data set. Okay, this is my data set. So here I have a data set of A and B. Okay, the one will be there. This is the independent. This is my dependent. Okay, dependent is particular output. So this is independent, this is dependent. So it is a simple linear regression. Okay, so I want to predict this is the I want to using this data point using linear regression. Okay. So here, see here, I'm passing the data. Okay, that is data.csv is my file. So here I have x and y. X is your independent, y is your dependent. So why I'm splitting the data location is for 0 and 1. It seems you have 0 and 1. I'm taking only the 0. That will be the dependent. I'm taking the 1 in the sense I'm taking the first column. I mean, first column and second column. That is, the column will be 0 and 1. That way I'm taking the second column of the particular value. I'm splitting the data set into dependent and I'm splitting data into dependent and independent. Okay, dependent is nothing but x value, independent having the y value. Okay, that is first column will be dependent, independent, second column will be the dependent. Then I just scatter by using x comma y. That is, I'm plotting the discrete samples. Then I want to show here. These are the data points of what I am having the Excel sheet. Okay. Okay, so next I want to build your model. See here, I already the first initial model P, M and C will be 0. Initially I told M and C will be 0. Then I have a linear learning rate, that is L equal to 0.001. Okay. Then I am giving the epoch will be 1000 times. Okay. I am 1000 times shall be running. So I'm just creating the number of elements, that is nothing but length of x. Okay. I want how many elements, that is length of x. So here I'm using the for loop. See here, we know y predicts not mx plus c. That is y cap. It predicts nothing but y cap. Y cap equal to m star of x plus c. Okay. Then we know dm formula. This is different derivative with respect to m. Minus 2 by n summation xi into y minus y predict. Y is nothing but I'm using I value. At the time it will become only one value. That is, I'm not. That's why I'm putting I value. So x star of y minus y predict. Okay, same thing. I want to show discrete time. I mean, I want to derivative with respect to c. Here minus 2 by n star of sum of y minus y predict, because here we don't get any xi value because we have derivative with respect to interrupt, that is c. Then I want what? I want to do update your new weight. What is the formula? M equal to m minus l star of d minus m. L star of d minus m. Then C value is nothing but C minus L star of DC. Okay, that's what we are getting here. That is M is new value. This is old value. Learning rate I pass is 0.001. Then d value, that is dm. Okay, dm is nothing, update m. If it is I want to update interrupt point, I'll get dc. I want to put dc over here. Okay, we'll do it. Okay, import pandas as pd. And then import numpy as np, then import matplot plot as plt, then I have data equal to, I want to take a data pd dot read underscore csv of my data is data.csv, and then I want to create x value, x is equal to data dot iloc of is2 comma 0 value, then y equal to data dot iloc of 1, let's square right. Okay, let me see, check and x and x value. These are the x value. Okay, 53, 40, 61 will be, just see here, it will be taken. This is the x value. Okay. This is the y value of your data. Okay. So I want to plot it. That is plt dot scatter x comma y. Then plt dot show. See here. This is the data point of my location, the corresponding x value and y value. Then I want to build a model. Initially m equal to 0, then c equal to 0. Then L will be 0.001 my learning rate. Then I want to put epochs. Epochs nothing but how many times my loop has to be exist run. N equal to float of length of x, because it has to be pass all the values. Okay, for I in range of epochs. Then we know y predict equal to, y predict equal to m star of x plus c. Then we know dm value, that is derivative with respect to m minus 2 by n star sum of x star of y minus y predict. Okay, so same thing, just copying. So instead of dm I want to put dc. So here x wants to come. Then I want to update my new value, m equal to m minus learning rate star of d underscore m. Then c equal to c minus l star of d c. Okay, so I'm printing the m comma c value. Okay, let me check it here. predict. Okay, see here it is running. I think I did a mistake. Delete. Here I put y star, sorry, y minus, right? See here. So my m value will be 1.47, then c value will be 0.1. Okay, this is my getting my output. So I want to print the line. I want to fit my line. That is y predict equal to, because we found out the m and c value, y predict equal to n star of x plus c, because we know m and c value. Now then I just plot scatter of x comma y. Then here I am just using some command here, plt dot plot of min of x, then max of x, comma min of y predict, then max of y predict. Then I'm marking as color. Color will be something red. Then I want to plot dot show. So plt dot show. See here. This is my best fit line of my project. I mean the data set. Okay, this is the best fit line. Okay, for getting this value, for updating this value. Okay, this is the building the model using least square. Okay, so next is this the prediction value what I'm displayed here. Okay, so next is linear regression using least square. So least square is nothing but you have the error. Same thing, you have to use least square method. Just to go through in YouTube videos, there are big derivations will be there. I'm just to calculate the m and c value. Okay, m is nothing but summation of I equal to 1 to n xi minus x cap yi minus y cap divided by summation of xi minus x cap of whole square. Then c is nothing but y cap minus m into x cap. Okay, this is the least square method for solving. See here, same thing you have to import it. See here. So here I'm exploring data. I mean, same thing, x and y will be independent, different variable here. Then I want to use here building the model. So see here, first I want to calculate the mean value. Mean is what numpy. I'm using numpy np dot mean. I want to calculate y mean also. The initial numerator denominator will be 0. I'm just using the for loop. For numerator is nothing but, see here, the formula numerator will be xi minus x bar whole square, y minus y bar. Same thing, that's why I'm putting here xi minus x mean, yi minus y mean. Same thing for denominator, xi minus x mean whole square. Then I want to divide it by, if it is numerator denominator, that will be m value. C value we know, y mean minus m star of x mean. That is y cap minus x of m into x star, I mean x cap. Okay, this is how you have to build your model by using least square. So you get the same answer what I'm getting them. But C you may cannot be get because interrupt will be changing automatically. Okay, this is the same thing. Just try by yourself. Okay, from formula. Then making prediction, that is also the same thing. Okay, next is what the last method, linear regression 6 line of Python programming. See here I'm using sklearn, that is scikit-learn of your model. This is inbuilt library you have it for machine learning. First, this is the data preprocessing. From sklearn, I'm importing the linear regression. Then again I want to split it as, I'm just reading the program. Then data 0 and data 1 will be x and xy. Then I want to make it as linear regression. So I have to pass the x and y data to fit your model. Then I want to predict my data by using passing the x value. You will get the corresponding scatter value of what I'm getting here with the same answer of what we get in gradient descent. Okay, this is the least square of method. This is general. We have already pre-trained model of linear regression just by uses of your data sets. Okay. So thank you for today class. If you have any queries, please you can.
Okay, I have. If you guys have any questions, you can ask in the comment section. And we have a question: why we use reshape in the regression model?
Yeah. So why we are using the reshaping instance is nothing but, for example, you have a axis data set that is a you have data set x and y, that is a two-dimensional data x and y. Okay, so I'm splitting as x will be the I'm splitting x will be the one particular one data type, then say y will be the one particular type. So linear regressions will be useful to predict your linear model. Okay, so make prediction accordingly. What I'm trying to say is same. You have input x and two arrays, that is x and y. Okay, so why I'm using the reshape in the sense x is because this array is required two-dimensional. Okay, so for predicting your future, we need two-dimension of your data. Then it makes it to good precision. I mean, good accuracies. Okay, that's why you have a column. I mean, to have a shape of reshape of your data set.
Yeah, I think the Agabalam is asking the question in a lot of different places. Actually, he has some issues regarding the assignment submission. You can ask the doubts in the Discord channel regarding your assignments. And we have a question. Sir, please give some suggestions to do masked face recognition. Which algorithm will be best?
It depends upon the data set. If data set is quite good, go for deep learning method, that is convolutional neural network. If not, I mean, this is two class problem. Just a logistic regress is more than enough.
Is the built-in functions in Python library for neural network?
Yeah, it's of course it's there. Of course, there is Keras that and all is there. Deep learning models to be there. You can use software.
We have another question, sir. How will you decide the dependent and independent variables?
Yeah, for a dependent is a good question, Junaid. So dependent and independent is nothing but, for example, if it is a simple integration method, simple in just one dimensional. I mean, whether x and y. Okay, if it is x is the independent, y will be the dependency. For example, you have more number of independent variables. Okay, more number of independent variables, but only one dependent variables. That is your output. Okay, we know that is in supervised machine learning algorithms. We know, for example, I'm giving the images of some object of glass. Okay, for example, that is a glass. We know that is a glass. Okay, that is a glass. The machine also knows that is also glass. Okay, that's why that dependent variable, the glass features are independent. Okay, the glass features are independent, but glass is your dependent. Okay, that's what I'm trying to say. So I will give one more example. You have a pen. Okay, you have a pen. In that pen, I have a cap, nib, then how much amount of the refill is filled. That and all features. Okay, that and all features. That are all the independent. Okay, so all are independent. Okay, because the cap will be some other cap also will be there. Then some other needles also will be there. Some other refills you can put in your pen. That and all independent. But dependent is what? That is your pen. That is a pen is your dependent. Okay, I hope this will be helpful for you.
Actually, why we are particularly using -1 comma 1?
You just check me and tell me. I told in during NumPy itself.
We have question in logistic regression and linear regression. Two types are there. What's the difference between them and why we have two types of them?
Okay, logistic regression is nothing but logistic regression is just a classification of your data. Logistic regression, but linear regression is not a classification. Okay, so logistic regressions have some other some additional features we having. So if it is logistic regression, it is coming into the probability. Okay, so what I'm trying to say in the sense, for example, if you want to classify two different types of objects, I mean two different types of image. For example, my images of cat and dog. So cat and dog, it has to be splitted by, I mean, machine has to tell whether this image is cat and dog. That will be used for, that will be happen by use of logistic regression. That is a classification. Okay, so linear regression is nothing but it will be prediction of your future data. That is, you have to find the best fit of your line. Okay, there you have linear regression. You don't have any activation functions. Okay, but that if it have, I mean, if you have more than days, I can teach of logistic regressions of a very good example. But due to some small amount of time, I'm not able to do this.
Yeah, and we have final question. I think we have reached the end of the session.
Hmm.
Some person asking, can you tell the difference between the classification and the clustering?
Yeah, classification is nothing but its classification can be both are generally we can say that they both are same. Okay, but in the in inter part of view, classification clustering is nothing but the clustering will be happen by use of feature extraction. For example, you are extracting the same type of feature into same object that will be grouping into clustering. Okay, but classifications you have to give you a label. Okay, that label data will be splitted by here. Okay, the classification finally you can give your label, but I mean clustering you have finally you can give your label, but classification you can give in your initial stage itself. Okay, for example, if you have ABCD, that ABCD you have to give into classification. But the group of letters I'm passing into the my machine learning algorithms, after getting the splitted by clustering, then you have to make it your label. That is a general difference between classification and clustering.
Yeah, I think we have reached the end of the session. Guys, if you have any questions, you can further ask in the Discord channel. And we have these assignments. You can submit the assignments. Only the person who is completing the assignments, those guys only will receive the certifications. Okay, I think it's time to leave. Okay, bye for everyone.
Thank you.